So, what type of pooling is this? In case you have to calculate, somebody has no answer though. Then we know the difference between average pooling, we know the difference between max pooling. What are they? One person. One person. That is Judas. What is max pooling? We said it. Ola, Steve. We said it. We said that in pooling. Oh, sorry. I'm not so. I won't be going back. I'm not going to be explaining the answer. I'm not going to be explaining the answer again. What type of pooling is this? Is this average pooling or max pooling? If someone now missed this one, this is cheating. No, it's not. Yeah, Emmanuel, we are not the one that's in charge of your internet. And join, you've not joined though. Akinola, welcome. We're doing quiz. It was announced. You came late. But it's with our question 9 of 30. So just go to kahoot.it, enter the pin 999662. Once you enter it, you can join the quiz. You're just on question 9 of 30, 21 to go. There's still a strong chance of, if I join the quiz now, I can still win. Should I join the quiz? Someone still miss. I should zoom the screen. You can't see the screen. Can everybody see the screen? Is it better? Some people still said, hey, Olaoluwa, what happened? Steven has answered 7 correct answers. 7 correct answers. That's impressive. Out of 9, he has answered 7. Which of these is not an activation layer? Activation layers. We have Sigmod, we have Tanch, we have Relu, we have Kosh. Which of these is not an activation layer? Question 10 of 30. We have reached one third. One third of the way. Yeah, most likely. Joy is Ja. Ah, Sig. Mudari. That's the simplest. It's all here. Where did we see Kosh? It's all here. Ah, Who? Thank God I'm not all of you people's lesson teacher. Mankere. Okay, let's continue. What is not a metric for measuring regression model? What is not a metric? Stephen is on fire. Stephen is all those people that will be quiet in class, but one cow, Jerry, one cow, which is not a metric for measuring regression model. And I know some of you already in data science, this is going to be breeze for you, So these questions are hard for me. I'm like, ugh. No, this was it's now second or third lecture where we said MSc, RMSc, MEA, MAE. Ooh, ooh, the war is thickening between MSc and RMSc and MAE, which is more robust? Between MSc, MAE and RMSc, which is more robust? Which is more robust? Deborah is not here today. Let me see. Hey. Wait, hold on. We need to talk. Did any of you go through the lecture notes? Did any of the 5? Because it is right here. Bolded. Bolded. Ah. Mhm. Okay. Um. Next question. Stephen is giving Joy run for money. Which of these is more sensitive to outliers? Which of these regression model is more sensitive to outliers? Which is more sensitive to Sunday? Are you on the? Are you on the? Which is more sensitive to outliers? Ah, you just said we just saw the answer that MA is robust. So I'm not talking again. Joy now miss it. So Steve in the law. Steve in the law. What's the formula for this error? This is the formula for what error? Is this MAE, MSC, or RMSC? This boils down to knowing what the definition is. What does MAE is? Let me give you a clue. MAE is mean absolute error. MSC is what? Mean squared error. RMSC is what? Root mean squared error. From that, I said the answer. Maybe it's me that even. That's good. Ah, Joy is not moving again. No. What's the formula for what error? The answer is in the name. If you can know it, if you just know the name, you know the formula. Hello? Okay. Sorry, my internet is disturbing me. Very good. Nine. I don't get to submit the answers till the timeout. Yeah, Sunday. No problem. Next quizzes we would, no problem. You and Emmanuel. This another lady. I've forgotten her name. Is she here? Ah, she's not here. Hmm. I've given you MA formula now. I've given you RMSC formula. You will have known that this one is MSC. Ah, Joy is the law. And Deborah too. Kelechi. 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 She's not here. Damn. What type of data is the number pi? Is it an integer? Is the what type of data type? What data type is the number pi? Tautology. Woo! Two people said character. No, it's not a character. Okay. 18, 12 questions to go. What data type is the number 3456? 3456. 3456. Is that not a character? Hmm, maybe. Oh, it is an integer. A number that does not have a point is an integer. Pi has a point because it's 3.14 kinikon, kinikon, kinikon. Right? Um, what data type is 3456? What data type is 3456? Code. It's a string because it's in quotes. It's a string because it's in quotes. Mhm. Now, in Python, an expression st Tolulope is the best test. Thank you, thank you, thank you. What is st minus 1 and st1? What is st minus 1 and st1? Is it t and o? If you remember, we did something called slicing or indexing of strings. Is it st? Is it s and t? Is it t and e? Is it t and t? Is it t and o? So it's the best test. Yeah, I am the best test. This one that is quiet. The answer is T and O. Hmm. Hmm. So, okay, we'll probably review these answers at the end of the quiz. Hey, Ja is back. In Python, for a matrix, math is this. What is math 01 and math 21? Math 01 and math 21. Yeah, I knew this would take a while. That's why I made this question 1 minute. So just, take your time. Only two people have answered. It's fastest finger, but fastest and rightest, if that makes sense. Six people. Ah, so for those that are joining with their phones, you can join in and do the quiz. So now we're going to we're going to review we're going to review the answers because it seems like some people are having problems with matrix indexing. What type of data is this? What type of data is this? Hi, Avila. You joined a bit late. Deborah is here, but Deborah joined with a mobile. Hmm. Oh, this is good. People can identify dictionaries, right? That's cool. Uh-huh. I think Steven stopped answering. He wanted it to be close. Oh, okay. He wanted it to be close. He wanted it to be more challenging before he answered another question correct. Ayola Oluwa. Yeah. You, Sunday, and Emmanuel have internet issues. Okay, 11, good. Hmm. Are these questions too simple? See, I'm sorry if network logged me out. I had to join with another name. Oh, okay. In D, what is D12? What is D12? What is D12? Don't worry, Niolua. I'm rooting for you. What is D12? Time with it on. You fell for it. A dictionary has a key value pair. Key value pair. Key value pair. So this is the key, this is the value, this is the key, this is the value. So that means 12 is a value. It cannot be a key. Let's see. Even the people on top. Hey, 25 of 30. Five more questions to go. What is D car? D car. D car. This should be pretty easy. Who said color? Some people Ensharo. 26. What Python library did we use to read CSV files? Jupyter, Panda, NumPy, Bear. Nice one. I think a lot of people like pandas. 27. Will Steven take this home? Can panda can pandas be used to read JSON files? Can we use pandas to read JSON files? Did you read JSON files? Did problem? Hmm. Oh yes, we can read JSON files with pandas. Ooh, 28. Can Joy can Joy beat Steven? Describing data frame. Describe in data frames tells us what? Summary of all the columns of the data, the top rows of all the columns in the data frame, the min and max of all the columns in the data frame, the bottom rows. Ooh, it describes all. Can Joy steal Steven's joy? Ooh. Mm, mm. 29. Add in data frame. Remember, it's fastest finger first. Add in data frame displays what? Summary of all the columns, the top rows of all the columns, the min and max of all the columns, bottom rows of all the columns in the data frame. Ooh, 9. Ooh, I think Steven is the winner. This is the last question. Tail in data frame displays what? Summary of all the columns in the data frame, the top rows of all the columns in the data frame, the min and max, the bottom. Avila, you're just joining. No problem. That's fine. We're at the end of the quiz of June. We're currently at the end of. Woo! Everybody got it. Woo! The only question everybody got. Joy has considered. Eh. So for this week quiz, Olaoluwa is the third, Joy is the second, and Steven is the first with 20,000 points. 20,000 points. Then Inyolua, wait. Inyolua might win, might still win. Hold on. Don't celebrate yet. Inioluwa, what's your second name? Can you type your second name in? Okay, we're going to add it. Podium, view summary, view full report, view full report. There are 15 people that played. So in got 7,191. And then Inioluwa, in and Ini, if we add it together, wait, Olaoluwa, you are not the third though. If we add in and Ini's score together, what was I saying? 12,749 plus 7,191. 12,749 plus what? 7,191. That's what? 19,940. 19,940. Inioluwa is the second. Inioluwa is the second. So, wait. Yes, Inioluwa is the second. So, from the look of things, as it stands, Simply Steven is the first, Inioluwa is second, and Joy is third. Congratulations, Steven. We yes. um um it was, at least now give us your feedback if you love the experience, because like I said, what we're trying to do is make sure we get attentive, and I'm sure in some of these things you would have learned one or two things. So if we go through the questions, right, I'm going to show all the answers. Which of the following is not a covenant layer? Convolution, pooling, activation vector. When we were discussing this, we discussed on convolution layers, and the layers in convolution, we discussed pooling, and other layers. Of course, there are still a lot: normalization, batch normalization, flattening, but there is no vector layer, right? Um, Second one was this. What's the formula for this? It is right here in what? It is right here. I minus k over s plus 1. When we're doing the simulation, that we confirm that answers with oh yeah, everybody. Steven won by switching tabs on one device. Are you serious? Huh. Steven won with one device. Wow. Wow. I'm sure there will be prizes given um for this. We'll discuss that later. Let's, because we are 45 minutes in. So we discussed this is I minus k over s plus 1, because these little metrics, why it's important is that these little metrics, why it's important is that these little metrics, right, um, will stand you out. I'm telling you that many people, many machine learning engineers do not know the meaning of these mathematics or significance. Okay, so we'll announce the final winners on Wednesday. We'll announce the final winners on Wednesday. So we'll do it Wednesday, people, and then everything. So don't worry. Yes. So after the class on Wednesday is concluded, we'll announce the answer. So let's just go through these questions. And please, if anybody is here that go on Wednesday, we'll just disqualify you. So now, that's I minus k over s plus 1. Now, what is s? If you notice from the questions, where I is the image, I can be, because I put I here in the question, I use L, right? I, K, S is what? Stride. So,
I
someone
have
messaged
one
me
thing to say about the formula. Can you go
the
back to
formula.
the formula? Yeah.
Yeah.
The quiz actually.
For the quiz. Yeah, this.
Are the parentheses in the right spot for the denominator?
Um, yes. This is supposed to be like this. Which one did you select?
I don't even remember. I just know I was really confused by the parentheses.
Yeah. So it's supposed to be this is supposed after this computation is done, then you now add the one to it. So if you notice for all of them, for all the options, all the parentheses stands, right? Are all the same. So it's just supposed to be maybe agreements with the signs and everything. That was just supposed to be where the trick was.
Okay, tricky.
Yeah.
But
Yeah. So that's why this, if you notice, some questions were 30 seconds, some questions were 60 seconds. So you can. So we have this, we have this. How many channels does the image have? This one pained me. Oh, it pained me. It pained me because we had two cute puppy pictures. And we said if it is colored, it is three channels. If it is grayscale or black and white, it is one channel. Oh, do no, but some of you did not look. You only look at this document when I'm looking at the document with you guys. Oh, I won't cry, but it's fine. Now, so we've answered these two. What is the stride in the convolution below? We did that. That is one. If you come here, the stride is one. Why is it one? Because it is moving one step. This black thing is just moving one step. If it was two, it would go two steps. If it was three, it would go three steps. Then next one. Where's the quiz? Let me close this one. Leave. So I just stop confusing myself. So output of compilation, what type of pooling is this? But we're clear on this that pooling, they can be max pooling or average pooling. Max pooling picks the highest of the numbers. Average pooling, we add everything and divide everything by the quantity of numbers. So this will be 20 plus 12 plus 8 plus 12 divided by 4. This will just pick the highest number. So, and most of the time people use max pooling because it is more representative. So average pooling, which of this is not an activation? Kosh is not an. I know people will say science Kosh tan, right? So Kosh is not, which is not an a metric MSC MA RMSC MEA, right? So which is more robust MAE, which is more sensitive RMSC. The formulas are just right. That was on lecture 7. The formulas are just right here. I just snipped those shots. By I think so far everything is explanatory. People really like dictionaries. So thank you very much. Congratulations once more to Steven. We're going to add your points and add everybody's points and agree with everyone on Wednesday and then announce the winners next class. Right? I should I should explain best test. Oh, okay. I should explain. Should I explain the word best test or I should explain the question best test? Which one do you want? Because I can explain how much best test I am. I get your point. Don't mind me. I'm just fooling around. So Tolu is best test. Yes. Let me see if I can zoom in. Ugh, why is this like this? Ugh, damn it. Ugh. Now, Tolulokpe is bestest. Now, this is a string. First things first, we know that what? Can we get access to recordings? Let's see 6, 7, and 8. Yes, you can. You can get access. It's on Google Classroom. Yes, you can. You can. It's already there. You already have access to it. Now, Tolulokpe is bested. Bestest. The matrix. Yes, we'll review the matrix too. Now, we said Python is a zero index language. So the first letter will be what? Zero. We also said that to access last term, it is what? -1. So string of -1 is the last term. And what's the last term? T. That's T. String of -1 is last term. Now, we also said that string of 1. What's the string of 1? O, because Python is zero index. The first letter starts from 0. The second one will start from what? 1. So that's why the answer is T and O. Inioluwa, make sense? Makes sense. Yes. Now for the matrix. Now, if you look at Python is a zero index language. So that means this is 0, 1, 2. Now, inside zero is another matrix. Is Python is a zero English. So let's go to 0, 1. The first zero is going to be this O matrix. Then inside that zero, we are looking for the first index, the 1th index, the 1th, not the 0th. So it's going to be 0, 1. So that's why it is matrix zero. This is the first zero. This is the first one. This is the first two. After that zero, this zero is talking about this whole list. Then the one inside that list, we're not talking of the one that is in one. If I say matrix 0, 0, it will have been this 0 and 0. For matrix 0, 1, it is this first one and then one. So that's why it is 1. Then 2, 1. So this is 0, 1, 2. So we are talking about this matrix. That's what the first two is telling us. And then 1 is the second term. That is 1 and 7. Make sense? Hello? Make sense?
Yes.
Yes. Okay.
Sorry,
So,
sir. I want to say something, sir. Hello, sir.
yes, please.
Yeah. I sent a message on the Google Classroom in respect to the classes
Okay.
because I noticed while I was trying to also play to have a playback on the section, most
Mhm.
of the visual, that's the video, was not showing. Only you and just looking at but the screen was not showing on the playback.
The shared screen.
Only your picture alone. I mean, your own.
Yes. Let's take a look at that. Shall you see all of you, all your attendance? Let's take a look at that. Let's see video lecture. Now let's look at this. Let's look at. So in this scenario, can you see what I'll be saying? So just to confirm, in some of them, maybe it's your internet. Right. Let me close that. So maybe it's your internet. Just check and review. So you can see that we've seen that. You can see my face. You can also see what is shared. So maybe at that time it was your internet. You had similar issues. Oh, which do you know what class? So we can check it. If you do, we can check it. And
Class
just
8.
class 8. Class 8. Class 8. Class Ejo. Class 8. This. So this is what I'm seeing. Make sense? So okay. See how I sound like. Yeah, I sound awesome. So now, so we've seen that from my end, everything looks good. So just check your internet, check your stuff, and then let's see if it gets better. So now, let's take a pause. We've done 1 hour of this. We've reviewed. Please, I will discuss with we dropped comment there if it's possible. It's the use maybe if you check the comments we dropped. So I observed the previous since okay, positive one. It's not showing your screen. Oh, maybe because it's mobile. Maybe because did you try it on mobile? Probably. Maybe that's why. Maybe we'll check it on. I've not tried watching it on mobile. Maybe that's why. But I will, and then I would get it across to you. But so far, this quiz goes to show that if you look at the slide notes, and if you go through the notebooks, this would have been such easy stuff for you. So there is still more work to do, even for Stephen, for Joy, for Inioluwa, for Olaoluwa. I was expecting every question answer because they were very simple. Someone sent me a message and said, "Oh, these questions are so simple now." Right. So um while I'm happy that I can see the participation, I can see the energy, right? There's still a lot that can be better. Hmm? Remember, we are competing with the world. Still have access to it. Yeah, I think most likely, yes, you should have access to it. Right. So because the goal is that as we are training you, you become so good you can teach this class for next cohort, right? And you'll be telling them your story about how I used to challenge you guys, right? So now, the next part of today's exercise, we have 1 more hour, is that I'm going to go randomly. Please, if you don't have your notebook, and please make sure you unmute. Once I call your name, you unmute. We're going to go random because last week we discovered that maybe based on feedback there was information overload. We're going to do something on classification. So right now I have a blank everything. I'm just going to be the person typing on the screen. You're going to see what I'm typing on the screen based on what you tell me to do. Right? So I'm going to go around. I can call Josephine, I can call June, I can call Emmanuel, I can call Sunday. Stevie will prove that he's the first. Can't wait to learn from Deborah, Joy, and Nini next cohort. Right? Stevie will show that he's the best because when I call him, he must tell me what I'm supposed to do in this scenario. Now, one thing in this next exercise is you can tell me that this is what you are going to do next. Go to that collab and copy this code. You must tell me the name of the code. You can tell me what the code is doing. If you can't tell me the name, describe what it's doing because that will show me that you have studied the code in the collab. So the next exercise is primarily going to be this. We are going to classify dog breeds. I'm a dog person, right? I'm a dog person, but I like wild cats. So thank you, enjoying. Thank you, enjoying. So in this next classification, we are going to do. Let's assume I'm your junior analyst. I am your associate, and you are just. But I'm not that smart because you tell me everything to do. That's the simulation we are in. So you have to tell me things as simple as type this, do this, copy this, paste this. Now I'm going to go around and call people and tell you, please, let's make it fun. Let's participate. If you don't know, it's fine. If you don't know, it's fine. We'll jump. You can volunteer someone else. Exactly. If you don't know, you say, but please make sure you know. Make sure you know. If you do, volunteer and say, if I call Emmanuel Odo is like, I don't know, call Emmanuel Jomo. Emmanuel Jomo say, no, call Emmanuel Oluwadimu. Emmanuel is Emmanuel. Right? Do you understand? So we're starting now. Scenario, I'm in the office. You are my boss, and they're telling you, I need a model to classify dog breeds. What do I do first? Who should I call? 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 The place of people is now refreshing. Are people disconnecting? Who should I call? Inioluwa, what's the first thing I should do? Please unmute. Inioluwa, what should I do first? Right now, I'm on this page now. Can you tell me, describe the problem to me and tell me what to do? Hello, Inioluwa.
Okay.
Yes.
Can you hear me?
Yes, I can hear you.
All right. Good evening. I don't even know.
Good evening.
Okay, so what we're going to do first is that, of course, we open our wait till we want to use Google Colab.
I'll open our Google. Yes, ma'am. Okay.
I don't know.
Google Colab. I open a new one.
We can open a new one now, and
A new one. Motishima. Yes, ma'am.
So you import on your libraries. I don't try.
No, but you've not described the problem. What are we trying to achieve?
Oh, okay. Okay. So what we are trying to do, so I guess we are trying to use like, is that not image? What's it called now? Image classification.
Yes.
Yeah.
How many breeds are we classifying from the document?
5.
We are five classes. What's the size of the data, man?
I can't see. Yeah.
You can't see.
Yeah, it's 5 now. We have
Is
French
Yes,
Bulldog,
but
German
what's the
Shepherd.
size of the data? Is the blackest part of the screen. The blackest part.
Blackest. Okay, 1,208 dogs.
What? I can't even see. Where do you see
I
1,200?
don't know. Blackest part of the screen.
So the size of the data is 660 megabytes.
So where did you see that? I just. Oh, okay. Oh, okay.
So what should you tell
Okay.
me as the analyst to do? I should
You
what?
download it.
I would
Download
before
it.
I import. You said import libraries. No, I should first what?
Yeah. Download your data. Get your site. All right.
No problem. So
Like,
is downloading. Once I download, what should I? You said I should open Google Colab. What should I do on Google Colab?
yes, now on Google Colab we import.
No.
No. Hold on. On Google Colab, you connect your, what's it called? It connects now. Yes, no, like you mount your drive, they connect all this blah blah blah. Make
So
sure that your
first,
Google Colab is connected.
yes, it's connected. Then
Okay.
I would
So
upload my what?
you can upload your data on the Google Colab space.
Upload my data on the Google Colab. Okay. So let me go and look for my data. Is an archive.
I can't hear you.
I'm going to look for my data to attach.
Okay.
Wait. Let me see. Archive 25. Upload. Downloads. Archive 25. Okay. So it is uploading 660 megabytes. Please, everybody, don't unmute, but a round of applause for Inioluwa. Makes sense? So she has taught us how to transition from Kaggle to Google Colab. Inioluwa, thank you. You did a good job. Some bumps along the road, but you did a good job. So next person. I want to call June. He's just coming back from work. Akinola, you want to go? Akinola has volunteered. Akinola, where are you? Next person, Anjorin. I have uploaded my data. It has uploaded. Archive 25. It has uploaded. What am I doing next? Anjorin. Anjorin, Jeka Anjorin. Anjorin. You people. Oh. Are you people shy? I'm not seeing you on your camera. Okay. Steven, what do I do next?
Okay. We have downloaded our data.
Yes.
We have uploaded the data to Google Colab.
Yes.
Okay. Now I think it's time we import our libraries. Import our
It's time
libraries.
we import our libraries. Yes, we would import our libraries, but okay, which library? Which library am I importing?
Okay, let's import NumPy as MP.
NumPy as MP. But what did she really?
Import pandas as PB.
Import Sir, I'm your analyst, though. You are supposed to know better than me. This is image classification. What am I using pandas to do in image classification?
Oh, okay. First of all, we need NumPy so that we can access the mathematical functions in Python, generally NumPy. Then we also need, you're the junior analyst, right?
Yes.
Okay, Mr. Junior Analyst, we will need the pandas data frame. We need the panda so we can access data frame. the data frame functions of pandas. Import pandas as PD.
Okay.
Okay, we are doing classification. Now the question is, one of the questions asks, what type of classification are we doing?
Image
Is it
classification.
image classification? Now, what tools do we intend to use? Are we using logistic regression? Are we using neural network for it? Are we using? So we start asking ourselves.
You tell me which one are we using?
Okay, I don't have that information, so let me consult the project manager.
No problem. That's fine. That's fine.
Okay.
So now,
Okay, let's
so
assume that we're using. Let's assume we
before
are using. Okay.
before we do this, we have imported our data. Oh, it's still downloading. Okay. We have imported our
Okay.
data as a zip file. You know, I told you it's
Yes.
best.
Okay. What on zip? Oh, sorry.
First thing is
Ah.
what we need to what unzip
Ah.
what
The truth
archive.
is, in my practice, I've not been doing this actually.
No problem.
I
That's
learned
fine.
this. I learned this, and usually I don't. I've not been uploading using zip file. So I learned this from last week.
No problem. You can also upload your individual data as a folder, but it takes longer time. But
Okay.
because we don't have that time or that luxury, that's why we zip. But even at that, if you are giving your file as a raw file, you unzip first. But if you are giving as a raw file, you don't need to unzip, right? So that's fine, right? So
Yes,
now,
sir.
because
Okay.
it's image classifications,
Yeah.
pandas only read CSVs, JSON, Excel files, and sometimes probably PDFs,
Oh.
right? They don't read
Mm-hmm.
it. So you don't need pandas for image classification. Rather,
Oh.
you need import what CV2 library.
TV2.
You understand?
Roger that. Yes, Roger that.
Make sense? Okay.
Roger that. Yeah, makes
So
sense.
now, what CV2 helps you read the images, and then we're going to use what convolution neural network. That was lecture
Okay.
8.
Okay.
ConvNet.
No, we
Convolution
didn't know.
neural
We didn't have that information.
That's why I said if you notice deep learning classification, it was what? Convolution neural network because it's images. Subsequent lectures where we were doing pandas, right? Where we were doing pandas, we were always dealing with what? CSV files.
Yeah, actually.
We were always dealing with what? CSV files. So CSV
So
files numbers are sklearn, data
yeah,
frame, stuff like that. Make sense?
yes, sir. So I think if the problem was clearer, the problem. Okay, for me now, I'm looking at a
You will
general
talk to
problem.
Inioluwa. It's Inioluwa that did not describe the problem very well for us. That's Inioluwa's fault.
No,
Right?
Allah. Thank you, sir.
No problem. No problem. So, Anjorin says she has audio problem. No problem. That's fine. That's fine. That's good. I am next person. Next person. Next person. Chisom. Chisom, are you there? Oh, you're at work. Ah, apologies. Apologies. I appreciate the fact that you're at work and you're listening into class. It shows dedication. Keep up the good work. Make sure you go through the notes and everything. Right? Inioluwa, you want to say something? Next person, let's call on Steven Showumi. Did I say Showumi's name? Have I said Showumi? Where are you? Showumi, come out. What do we do next? Showumi, are you there? So this it has uploaded, finished. Let's unzip. We've unzipped. We are unzipping or currently unzipping. It is unzipping. So that's the first thing. I'm going to quiet this out so that I can get my space back. It's going to show now. So that is there. Chisom is at work. Showumi doesn't want to answer. Is Deborah here? Deborah, are you there? Deborah, can you talk? Deborah, all my students are not participating. So if we look at the folder, in short, wait, let me firm. June, can you talk? I know June is most like usually engaged on weekends. June, can you talk? I know you're back home. And Joy has nominated Emmanuel Ojomo. Emmanuel Ojomo, can you talk? Everybody is quiet. Let's make this fun. Let's go.
Yes, I can talk.
Okay. Who said they can talk? Emmanuel or who?
Yes, Emmanuel.
Yes, Emmanuel. My first question. I went to the project initiative. They said I should download the image. I went to, project initiator 2. They said I should upload, unzip, and import CV2, right? I've imported it. Don't let them fire me. This is what the folder is telling me. What is this folder telling me?
It's telling you the category of data you have. Like yes, like for the French bulldog, it contains data pertaining to the French bulldogs, yeah, pictures and then some other things in it.
So it contains like
And
JPEGs, right? But that means that
yeah,
that's the model. Python is zero indexed. That means that when I train the model finish, this will be whenever it says 0, it is referencing French bulldog. Whenever it says 1, it is referencing German Shepherd. Whenever it says 2, it is referencing Golden Retriever. Whenever it says 3, it is referencing Poodle. Whenever it says 4, it is referencing Yorkshire Terrier. Does that make sense? Am I
yes,
right?
it does.
Okay.
Yes, yes.
Am I bínú pé mo ṣíwájú yín sọ̀rọ̀? Or do you speak Yoruba?
Yes, I do.
So this is what this is telling us. So how can I view the image in this file? How can I view it? Let me be sure that it's a dog that is inside. Because sometimes some data can be, terrible. How can I view the image?
I'll try. So you intercept the French bulldog from the main data set, and then you try to read through or view through
I will
so
read
that
it.
you can access,
How
or
will I
you
read?
better still you open, sorry.
I will read it through CV2. That's why this is important. CV2.image read. I will now access it that it is where? It is in dog underscore v1 slash French. I want French bulldog slash. This name is too long, so I'm going to come here, right click. I'll say rename file. I'll copy everything. I'll paste it, and you can see that it has read it. So there's a syntax me I'm not sure of. I think is what 2 dots. I am sure. Make sure. Yeah, I knew it. Me, Canada. So now I'm going to come here and I'm going to say, oh, I use Matplotlib. So I'm going to import Matplotlib, bring it here. So feel free to go through the image while I'm asking you. That's the notebook I'm using. I like the way this is going. So now we come here and then you can show the image. Let's see the kind of bulldog we have. All right, let's see bulldog. Ooh, for dog people, they like it, right? So this is showing that we are verifying the image because sometimes they can go and put image of a car now in between the dog, right? You understand? Let's check another one. So sometimes, right, you need to check everything and be sure that everything. You're an analyst. You trust, but you what? You verify. Hmm? This is another what? Bulldog, right? Good. So we have verified bulldog. We can verify German Shepherd if we want to. We can verify all of them. Make sense? So far, makes sense. Emmanuel, thank you very much. Joy is just looking at a picture of dog and saying, "Oh, Joy, what do we do next?"
Not you putting me on the spot. Actually, I have a question before I try to answer what to do next because I'm looking at the notebook. It looks like we imported the zip file library, but we didn't do that here, and we still were able to unzip the file. What is
What's
the
zip file library? Come here, where is
so
it? Which one?
up there
Import
after
zip file.
OS?
So some already come with, by default on the collab. Usually it's not. And this zip file, so there's something about collab. Whenever I put an exclamation mark before something, it is not Python. I'm already typing in command prompt or in Linux. This is a Linux command just to unzip file. That zip file library is a way to zip files into a tuple. It's different from this unzip file.
Mm.
This unzip is just a command. It's just like when you have your command prompt unzip or tree or ls that shows your directory. This is one of those commands that comes with the OS itself. So this is kind of like a Linux Python environment. If you want to type in Linux, you use exclamation mark. If you type ordinarily, it is a Python environment. All right. So that zip file is used to. Let's just do this. I know I've used it before. Zip file, zip file Python. Alright, tell us what it's used for. Zip file Python is used to archive, is used to compress modules, to create, read, write, append to a list. Provides a create list. It's just kind of like using lists but attaching values together, not necessarily stuff. But and I think you can use it to save to zip too. If you're writing a data frame to save to zip, but that's something else. So what do we do next? I know you've asked the question to take your time to what we're doing. So
I
what are
don't
we
know
doing?
what we're doing next. So in my mind, we're pre-processing or we're trying to understand the data. So we just looked at one of the or a few of the images in each of in a folder. We're probably going to want to create a model, and I
We're
know
going to
we're going to want TensorFlow
we're
because
going to
we're
want TensorFlow to import TensorFlow.
yes.
Steven, we use TensorFlow for um import, TensorFlow as what TF, right? So we've imported TensorFlow. Then what should we do?
We're going
Joy,
to create a model.
we're going to create a model. What type of model?
Mm,
We're going to create a
an image
sequential.
generating
We're going to create
model.
a what? A sequential model. If you come to the notebook before, it is what? So she wants to create the model first. We're going to create a what? A sequential model. So let's come here and take this model.
What do you mean by sequential model?
So it does its processing in sequence. So it refers to convolution, to pooling, to conv, to this, to that, to that, that. There are some ones that is dynamic, which I've not worked with before, but all those, Bados use. Most of the times we use sequential models. So now we have created our model, right? We have created our model. Hmm? But I think this is putting the cart before the horse. Because before we think of model, we have to think of the data. Now, if you look at this data, it is at about seven. Let's shall say 750 by 1000 and one something something something. If I look at another data, if I look at another data, right? Control A, Control C. If I look at another data, let's see if it obeys the same rule. This is 1000 by 1000 or something. All the images have different sizes. We need to first align that
Mhm.
we want all of them to have the same size before we think about the model. we first need to deal with the data, because the model is the easiest part. See, I've copied the same model I've been using. I've just been copying and pasting the same. It's the easiest part. In short, it's the part where I just say I'm training the model, boom, I go and take chocolate in the office. For your data, the strength of your data, how clean your data is, determines what your model learns. And if your data is bad, your model will become dull. Your model won't be artificially intelligent, it will be artificially dull, right? So let's first deal with the data. So first things first, we have done this. Here, these are the activation layers. It can be ReLU, it can be Sigmoid, it can be whatever we say we want it to be. For this one, let me change this to ReLU. This one, let me remove one convolution and max pooling layer. Let's just make it different. Right, let's just make it smaller. Let me change these numbers to 60 and 27. Now, the output of this model, what is it going to be? How many things am I classifying? Josephine, are you there? Josephine, are you there? Josephine. Josephine is not answering me. Okay. No, Anjorin said one. No. How many things am I classifying? I'm classifying 1, 2, 3, 4, 5. I'm classifying 5 things, 5 classes of dogs. Right? 5 classes of dogs. It is written directly in this folder. 5 classes of dogs. So the last layer of the convolution layer will no longer be 7, but will be what? 5. And this 5, it will display it as 0, 1, 2, 3, 4. 0 for French Bulldog, 1 for German, 2 for Golden, 3 for Poodle, 4 for Yorkshire. Make sense? Make sense? Enjoying. So before we move, I don't want to keep us more than. Before we move to the model, now we've done the model. Let's just keep it in the background. Let's make it leave the screen. We don't even want to see it. Joy has taken us to the future. Joy has taken us to the future. Let's leave the future where it is. Let's take it away. We'll come back to where it is. We first need to deal with the data. Now, what do we do? Last week, Anjorin, yes, I know you are saying okay, but do you understand why it is not 1? Anjorin, are you there? Does everybody understand why it is 5?
Yes.
Yes. Okay, good. Who is there?
No.
Dari. Manuel. So if you look at the last thing we did, right? In this place, we did car classification. If you look at the car classification, there were 7 folders there. Because there were 7 folders there. Now, this is what we are supposed to do before we go to the model. Joy took us one step back. Now, 7 classes. These 7 classes should be here. 7 classes. Right? There are scenarios where there should be 8 classes. That is standard case. That is more advanced. Right? So what we do generally is machine learning models have a weakness. They are not that intelligent. That's why their intelligence is artificial. So someone like me now, one part of my research when I was in school was how to fool artificial intelligence. And I was able to successfully fool artificial intelligence. But to unfool it, there are some things you have to put in place. So normally, and this is one thing I am telling you that not to confirm which of our one of our particular image belongs to. I don't understand what you typed and join. Just you can, if you want to unmute, you can, or if you want to rewrite your questions. So now this is one thing many machine learning engineers don't know. I'm telling you secrets. Many don't know. So if you are classifying 7 classes, classify, add 1 more, 8. That 8, let it be anything that doesn't belong to the 7. So yeah, I want to classify dog. I'll put random junk. I'll put farm, gun, goat, shoe, anything, and put it in the 8th class. so that if anything is given to the model that satisfies the size of the model, for a machine learning to qualify, you just need to satisfy the input shape. So if they go and give it goat and it's supposed to classify dog, or they give it something else and it's supposed to classify dog, it will still, because it's an input image, it will find the closest one to the dog if it is just 7 or 5 classes. But if you put one additional class and say all the jogbon or random things you can see that does not satisfy this 7, put it in the 8th class. No matter the image, but that is advanced. I don't want to confuse. This is a digression, please. If you don't understand what I'm saying now, forget it. It doesn't affect anything. I'm just telling you that these are some of the ways that you'll be like, oh, when you're in the office, let's do this, just in case the stuff is on the field, it won't misinterpret some data. Do you get it? So you just know that classification 8, ignore. Do you understand? So, but that's that. By the way, your workspace is wild. Thank you. Don't mind me. Don't mind me. That may be a compliment or an insult. So I'll take it as a compliment. So now we're going back here. Now the term for the next thing is called data augmentation. After we've gone to Kaggle, we've taken the data, we've uploaded the data, we've seen the data, and we've verified the data. We're now going to do what? Data augmentation. I know, Inelo, I don't mind me. Is what? Data augmentation. What data augmentation we do is that you take all the images, shrink them down to the same size, right? Shrink them down to what? The same size. When it shrinks them down to the same size, it will now do what we call zoom in, zoom out, because, for example, so this is there's no problem. You can copy and paste the code. There's no problem. Nobody's catching you. Right? In school, where I am, most of my tests are open book. It's not, Nigeria, you have to cram everything. Open book. Do you understand? They will now say that you should bring cheat sheet. They'll say you should bring cheat sheets. It must just be 1 page. Many of my Nigerian, don't worry, all of us, what we do is that in that cheat sheet, we will divide it into 8 columns. We will write all our notes. We will not read it to all our notes on it. Are you saying you set the parameters for the 8th class in such a way that any image outside the first 7 will return? If so, Deborah, yes. So Deborah is asking question on the digression that I will set it that, so say for example, I'm only classifying dogs, but what if a goat comes into the frame? What if a lion comes into the frame? What if a tortoise comes into the frame? If I don't have that extra class, it will convert the image of the tortoise. That's why they are dog. Garbage in, garbage out. And do the mathematics and give it the closest relationship. So if you are saying, you are creating a model to tell you how many dogs comes by, right? It will just say that all the dogs, 17 dogs come by, even though the dog is a tortoise, even though the dog is a goat, even though the dog is a cow, even though the dog is a this, right? But once you create a code that, once it brings out 8 class, the 8th class, ignore, don't count. You will know that it was specific. So you put random animals, random goats, random objects, everything. So usually many times you have a folder of random nonsense. But we'll make sure in that folder there is nothing that is what we are classifying in that folder. So it can be man, dog, paper, anything random, and just put it as the 8th class. So whenever the image sees anything that did not resemble this, put it here. Something like that. Deborah, I hope I answered your question. So if it's for cars, can you think of the step like data normalization? Can we think of a step like data normalization transformation for numerical data? Yeah. Deborah said that is brilliant. Yeah, I know. Yeah. It's actually something I wrote a research on that contributed to. Don't let's go. Grad school was not. I don't want to remember. Well, I will share you some of my publications so you can go through it. Right, I came up with an algorithm for multi-class, multi-level, and it was really good, really good. So we'll delve into that some other day. So it's called data augmentation. Now, I'm telling you this because I discovered this technique by myself when I was discussing with my supervisor to propose a technique, right? This was basis for my PhD. Now, many machine learning engineers, and I'm telling you this, even the ones in my office, they don't know these things. So now, many people just think, let's go on YouTube, let's do a course. Yes, that's the first step. You joining this bootcamp is the first step. But when you get the job, how will you stand yourself out? As you know, I am a machine learning engineer. I am the principal in my field. It's these little things. Training your model with the smallest parameters so that it can achieve the smallest size and be the fastest. Training need to have the best accuracy. Stuff like this. Training need to be able to be strong enough for noise. So if you are classifying dog, if it is a goat, it knows it is not in this category. I bind it. If you are classifying any other thing, it's not in this category, get out. All those things are little things that will stand you out as a state of the, world, machine learning engineer. So there's something we call, sorry for the digressions. How many minutes we have? We have 25 minutes. We are going to do something called data augmentation. Data augmentation, if you remember last week, is a situation where if I want to classify a remote, right? Imagine I take all the images from this distance. Can you see me? Okay, yeah, this is the camera. Imagine I take all the images from this distance. What if they give me a remote at this distance? Will my model be able to classify it? What if they give me the remote at this distance? Will my model be able to classify it? What if they give me the remote here? Will my model be able to classify it? That's why we need data augmentation. If you remember, it will rescale it. So what Joy was saying, normalization. This is normalization. It will rescale it from 0 to 1, reducing all the noise. So little noise will go to 0. It will rotate the image. So I'm taking the picture of the remote like this. What if I take the remote like this? What if I take the remote like this? What if I take the remote upside down? Oh, sorry. This is the remote. What if I take the remote upside down? What if I take the remote sideways? It will rotate it. Now, imagine I'm taking the remote like this. What if they horizontally flip it like this? Or they horizontally flip it like this? You understand? So there's horizontal flip, there's zoom range. So what the image data augmentation will be doing is it will be zooming the image, take some image like this, train the model on it like this, train it like this, train it like this, train it like this, train like this. It will be zooming it based on what you set. So in this place, it will zoom it by 20%. So all these things are called data augmentation. Introduction of all these noises or all these perturbations will make it will make the model more resistant to noise on the field. Because what if you are taking picture and all those kids, maybe they are skating or they are playing ball or they are throwing banga, and the image you are supposed to classify, someone just pick their nose, and when they pick their nose, they put it on the image. That small pebble, it has changed your image. So that noise, by the time you normalize it, that thing will go to 0. That noise, your image will still be okay. Now, Deborah is asking, what is the number 255 representing? Every image. That's a good quiz question. She will have missed it. Every image is between 0 and 255. 0 means black. Every image is made up of pixels. Each pixels can be shrunk to integer. Zacchaeus. Zacchaeus, are you there? This is the first time I'm seeing the name Zacchaeus. Zacchaeus, be ready. You're talking next. So black means 0, white means 255. So all the color spectrums, RGB, blah 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 blah, are a mixture of numbers between 0 and 255. So if you are working on PowerPoint or something and you go to your color code, you will see it's 0, 81, 92 is a color mixture this is a color mixture and everything. You can get the Bravo answered your question. So 255 is just image pixels. So 255 is the highest number you can get. So if you divide it by 255, your image pixels now range from 0 to 1. 0 to 1. So it will be 0.98. So if a number is between 0.86 and is a noise, and the place is supposed to be 0.85, but the noise made it 0.86, the difference is now better. Unlike if it was supposed to be the real number, if it was 250, maybe it's 256, and you put a dark color on it, is now 289. Sorry, not, it can't be 280. 240 something. Is 40 difference compared to 0.1 difference. So that's what this will do. So after checking the image, what you do is what? Data augmentation. What we use for data augmentation is what? Image generator. They've created this library for us. And this is what they do. Now, this library will help us change this image from what? Into trained data sets, test data sets, validation data sets. It will do it for us. So now I'm going to come and change it. So if you look at, this was from the car data set, right? I will just come here and say dog v1. I'll just come here and say dog underscore v1, right? I'll come here too and say dog underscore v1. And what will it tell me? It will tell me that it saw 10,030 classes, 10,030 images that belongs to 5 classes. Why is it 5 classes? Because there are 5 folders. So this number of class that is 5 here, I will bring it down here, and that's why I will name this 5. Make sense? Something is wrong though. Coming. That's all done. I'm coming. Let's continue. There's something I will fix and bring back to you. So after data augmentation, then we'll go to the what? We'll go to the what? Model design, which we've done. So far, is there any information overload? Emmanuel asked, what about making the number of classes 6? Now, if you remember, for now, let's just deal with 5, which is the number of folders. Let's just do that. And let's understand this basic first before we try to be advanced, right? There are many techniques you will learn that I might see your technique and say, why didn't I think of this? This is wow. You understand? This field is very, the research space is not saturated at all. You understand? So anything can happen. So we've created the model. Olaoluwa, is Olaoluwa here? Olaoluwa da. Adedayo, are you here? What do we do next? I'm assuming as I'm saying on my story, all of you have gone to study the other notebook. So after data augmentation, we've done the model. What we need to do is what? We need to create an optimizer and also hyperparameter. What are the number of epochs the model will train for? What's going to happen? So just come to the other notebook. Don't worry, you can copy. So now let's print the model summary. Let's see what's the size of the model we have. The model summary is telling us that our model is what? 7.14 megabytes. I think this model is too large. It's terribly too large, but we're going to use it like that. 7.14 megabytes. It has 1,870 parameters, 903, 1,807,903 parameters. Now, please, am I going too fast? The class is too quiet. Nobody has interrupted me.
No.
Everything is fine. Everything is entering, syncing. It makes sense. It's not like last week.
Can I just make a request?
Yeah.
Yes, please. You can make a request.
Can you please just like put notes for like what each step is, just so we understand why each step leads to the other? So I think
I would rather
comment.
you come next class and ask me questions. I want you, if I put notes and you read it, you feel overconfident. I would rather, you come and ask me questions. And so I want you to go after now, check the notes. This is what he said last week. Go check the video. See, he did not explain this. What does this mean? That I don't want to bake everything so granulated.
That's
And if that does not work, then I'll put notes. But
okay.
I want a situation where I have a feedback that people are reading the coursework. So far, there's no proof, no evidence that people are reading. Yeah, so me too, I was surprised. Samuel, any questions? So we've seen our model is 7 MB, then we do our optimizer, blah blah blah. So just Control C. Do our optimizer. In this scenario, I want to use Adam. There are different optimizers, right? I want to use Adam. Did I import Adam, right? Okay, let me import Adam. So there's RMS drop, but I want to import Adam. So I've compiled my model. I hope you understand why this is categorical, because there are different categories. There's binary categorical, which is if it's just two classes. There are different things, but this is it. And I want the metric I want is accuracy, because it's image classification. There's if it is regression, I'll have used RMSC, MAE, blah blah blah. So, and then what's the next thing? It's that simple. Train your model. 4 steps. Train your model. Let's see how good or bad this is. I haven't trained this. So we are training for 100 epochs. You can train for 200 epochs. You can train for 500 epochs. All right. Let's train our model. And so far, that's it. Train your model. It sees what it looks like and it tells you if it's good or bad. And then that's it. There's a question since I did classification. There's a question I've been waiting for people to ask me.
I have a question, maybe not the question you're thinking, just something that popped up in my head. So you were saying that the model is super large, and I know that's ideally we want a small model with the highest accuracy. What would you do to reduce the model? Like, would it be just tweaking the parameters, or like what would you generally, like rule of thumb, do to reduce how large a model is?
So there's something I want us to do next class, which is all what she just asked, right? Some smart people have gone to the future. So before, this is what machine learning engineers used to, smart people. That's why they pay them a lot of big money. But the machine learning engineers now went to do it that, there's something called NAS. NAS is called Neural Architecture Search. NAS comes with AutoML. So now there are some things now that you don't need to, all this one that we're doing manually, so that you can understand it. There are some things that will help you select the model. It just tell you, what's the maximum size of model do you want, or what's the maximum number of parameters you want. You understand? What's the maximum number of, if you say I want 1 kilobyte, it will search for the best accuracy under 1 kilobyte. If it comes with 55 accuracy, that means you should increase it. That's something I wanted us to do this class, but I want you to see the manual approach. See the beauty of it, and then we will do NAS. what does the number epoch why does the number of epochs matter? What are epochs? I must have missed the last list. Um Epochs is just, so I'm going to use the best way to explain it is that, okay, imagine when you were preparing for WAEC, when you were preparing for NECO or for JAMB. Some people will buy only, maybe I'm doing JAMB in 2024, right? So people will just go and study 2020 to 2024 JAMB questions, right? Some people go and study from 2020 to 2024. In my own time, when I did JAM, I went to 1980 and I solved all the math questions for JAM. It's not because I like math, it's because I failed JAM, right? So that it's not happening to me again. So now, epoch is the number of times you will be exposed to the training data. It will fragment itself so that to expose you to the training data. It's just basically time. There's a definition for it, which I can't remember now, but it's just the number of times you're exposed to it. So the number of classworks you're exposed to, the number of times you're exposed to the classwork. So if I say, for example, 5 epoch, I'm sure 5 epoch will not run through the whole data, right? Or because I put steps per epoch, right? So I'm going to stop this. Yeah, stop. It's still it's into this. Okay, yes. Okay. So if I do this, if I remove steps per epoch makes your training go longer. How does epoch differ from backpropagation? Blah blah blah. That is started the runtime. And this. So you will see, because I put 100 epochs, it will you will see that the steps per epoch I put by 8, it was only running 8 times. Now you see it will not run 8 times now. It's going to run for probably 15. Yeah, should be 15 because there are 1500 images. It will run 15, but it will be very slow. Oh, it ran for 9. Steps by epoch. 100. Okay. 900. 900. I'm coming. Then it probably took the rest, the 20% for. So the other 600 will be for the other 600. It will expose what he's saying there is going to expose the training set data to what? 900. And then it will expose the rest will be for test and the likes. Yes. Why does epoch matter? Epoch, the more the epoch, many times people don't like much epoch because they want your data to train as fast as possible so that it can meet time to market. Now, the process of training epoch differ from backpropagation. Backpropagation is when you check the loss, find the differential of the loss, and add it to get the weight. Backpropagation is the principle of guessing your weight, fine-tuning your weight in training. Backpropagation is training. Your model will start with blank guesses of weights, 0.1, 0.3, blank guesses of weights. It will use this to classify the model. The model will get your loss, which is that you said this thing is 8, but it's supposed to be 7. The number of epochs complete. Yeah. Complete plus on the entire data set. Number of epochs, yes. Determines the data we go through. Too few epochs will lead to underfitting. Yes, yes. That's good. Thank you, Joy, for adding it to the class. Adding those notes to the class. I should have done my quiz back to Israel's time. People will have missed their distance. So this is going to probably take a while. Every epoch step is taking about 89 seconds. So, but this is ongoing. So far, right now, any questions? At least compared to last week, this makes sense, Abby? Yes or no? Hello, are we there? So far, any questions? Please unmute any questions. Interrupt me. The class is too quiet. Hello, Josephine and Johnny, June. Nobody is talking. Ah, Ejo, Ebami Soro. You are learning. You see, all of you say you are learning, you are learning, you are learning. You only learn on Saturdays. When I leave now, nobody will open this paper again. And shame me, it's paining me. Am I wrong? What is it? Please. You do. I know. I know some of you do. I know some of you do. But some of you don't. Some of you don't. Some of you don't. So you're learning. Don't worry. It's fine. I know how you are. And yes, assignment project. So what I plan to do is that in the classroom, when I upload this material, I'm going to upload. Use the notebook. Use the notebook. Use the code. I dash you. You can use it in your machine learning career. Take it. I got it from the internet too. You are fine. I'm going to send you, check the notebook, and I'm going to see how I'm going to use the notebook, do whatever you can, and I'll attach two images to I'll attach two links or data sets where you would, do image classification and do regression. My last question is this before we go. We have 5 minutes. So we understand this now. We understand it better. Please go through the notebooks. What if you're in the office? Imagine you're in the office, and you work for, let's say you work for Dangote's refinery, for example, or a welding company, right? You work for them, and you just get the idea that Oga, this is how you people do this process. We can make this process better with convolution neural network or with a covenant. Sorry, my only issue is that the audio keeps cutting, and especially is what issue when we attempt to do what we have. I have no idea. Sorry, my issue the audio keeps cutting. Installations. This you understand? I don't. June, you can unmute to talk, but I don't understand what you typed. So what if you just have the brightest idea? It's only you that have the idea in the world, and you are like, yes, please.
Yes, please. Okay, can you hear me?
Yes, I can hear you.
Yes, I can hear you. So what I'm saying is that the way you guys explain the classes, they're very simple to comprehend mentally, right? So the issues usually come in when you attempt to carry out an assignment and then it's not working the way you thought you comprehended it. So I would have suggested that maybe we actually have a whole class where we're actually carrying out an assignment together, and then whenever we face a bottleneck or two, then people can ask questions to get a better understanding. Because even if you go back and listen to your video, of course you're a professional, you're explaining it in ways that sound so easy and so simple to comprehend, which is different from actual practice when you actually want to practice what we have been taught. That's what I was trying to say.
Okay.
Yeah.
That's a very good suggestion. So what I plan, or after this class, the plan was that I'm going to give everybody data sets. I'm going to give you one on regression and one on classification. So I'll send images. So in the course of the week, download, install, face your challenges. In the course of the week, drop message on chats. I know some you will face situations where you'll be frustrated, you will slam your laptop. Don't worry, we've been there, right? And in the course of the week, drop chats, drop messages. I will attend to some of them. Israel will attend to some of them. But the next Saturday will be that I have a question. When I was going through this is we might even give you possibility of sharing your screen, and then we go through all those things, and then in the course of week, everybody will at least be on the same level. If you come and spend 2 hours, 2 hours won't be enough. because everybody will have different problems. Make sense? Can you please help the group? Some of us are lagging behind, some those ahead of us. Yes, I agree. Everybody is on different levels. Some people have, some people have issues from Python. Some people have issues from data frames. Some is just machine learning that they have. So to go back and forth, up and down, but when everybody have specific questions, it's just easy to go pinpoint. And then everybody, I encourage everybody to ask questions, because your questions is questions of a huge bunch of people. So shedding light to what your problem is, we shed light to what a lot of people's problems are. Right. Inyolua says, I have a question though. Inyolua, please. What's your question though?
Yes. My question is that what if, like, we were trying to view our data at that time, all those images. What if I open an image that is supposed to be a puppy and I see a cat?
Ewo. What do you do then? I'm asking you, what do you do then?
I don't know. Maybe like maybe like it's supposed to be a French bulldog or something, and then I see a German Shepherd, or I see a very cute cat or something.
So what you do is, so this is where you now have to come and do something like this. Once you see that you can't trust the data source, you come and do something like this. This is now the control of machine learning comes in. So we are in the stage where we are collecting pre-processed, already organized data. What if they tell you that the idea just come? I work for a pet company. I work for a pet company. What if we do machine learning to identify pets? They will now say, where do we get the data from? All these people that will be saying cute puppies. Let me close the screen so that we can listen. You understand? What do we do when we? What do we do? Where do we get the data from? Say we now go and hire a photographer and be snapping picture of everyone. No. That's where you now do your cleaning. Now, some people that are recleaning the data, right? They may mislabel the data. They may put cats because they are drowsy and because a lot of images. They may put cats. They may mistakenly select cat and put it there. Now, when you train your model, right? Your model will actually train and your model will actually work. It will just tell you that it is confused in some areas, that it is seeing cat as dog, right? It will work well. So far, many of the cat images are not there. But as you continue to retrain and you continue to retrain and you continue to relabel, it will keep forgetting that, because it's just one image of a cat. It will keep forgetting cat and reinforcing itself as dog. So you don't necessarily please be very attentive to detail, be very, straight to the point, be very concise. But if out of 1,500 images, there's just one cat image, I'm not encouraging it. Please, I am not encouraging it. I go through the painstaking task. Of going through the images. So this is what I do. Let me just tell you my own approach. Don't tell anybody. What I do is that, let's say they give me fresh images. I don't know. Maybe it's 200,000 images. What I will do is I'll go through the painstaking task of checking 500 for cats, 500 for goats, 500 for this, 500 for that, 500 for that, 500 for that. Once I do that, right, I will train an image on those 500 images. I'll now use that model. I will train a model on those 500 images. It still remains 200,000. I'll now run that model on 200,000. That model will now tell me the one that you have high confidence that is a dog, save it in this folder. The one that you have high confidence that is a cat, save it in this folder. The one that you are confused, save it in this folder. So if I'll now put the confidence threshold, if it is 90%, save here. If it is between less than 0.6% Xavier. That's confused. I will now go through the folders of it did well. I will see dog, 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 dog. Anything cat, I'll remove it. It will be very small cat. The one that is cat, 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 cat. The one that is confused, I'll now say, okay, very because it will not be 200,000, maybe 1,000. Cat, dog, and I'll split it. So that's what I do. So I train a model before the model. That model simplifies my task. So I do the mini automation. But a lot of what I just said, forget it. You may not understand what I mean, but as you practice more, you'll see where it comes in. So at what point of exposing the data to the number of epochs overfit? For example, look at this model. The model on the screen is showing overfitting. Out of 10 epochs, right, 11 epochs, it is still ranging between 23. If you see the classic is the accuracy is oscillating. So it was 23, it dropped to 20, 20, 21, 21, 20, 22, 20, 23. It's not learning. We'll still leave it for a while. But right now, from the look of things, it's not learning because the first time you saw the model it was 23%. And the 10th time you saw it, it's still 23%. It's not learning anything. Right now, in a scenario, it's not learning. So we need to come and fine-tune. There are scenarios where we will encounter this. We need to either come and increase our model size. You understand? Maybe some losses are there. So, for example, I just went through the images and I saw that there are images of people's hand, there are images of background. So this hand is probably as equal to the percentage of the dog itself. You understand? So the data in itself is not clean. Look at this one is very clean. This one is very clean. But this one, images like this, there's color, there's everything. This is the only thing the model has to check. It's a dog. So we either need to come back to check the image, right? Or we need to come back and say, we need to increase the size of the model, right? So I'm going to let it run for like 50 epochs and then see. If not with the class, I will check it and then show you the recommendations I did next class, right? Any other? Yes, there's a question some you are supposed to ask me. There's a question you're supposed to ask me. What if you don't have the dog images and you have to search for the dog yourself? What do you do then? These people have separated the dogs for you. What do you do then? Hello, can somebody suggest to me? What do you do then? Your boss comes. We have an investor coming from China. He wants you to identify all the bears, a model that will identify all the bears in the world. All the bears, bears now, like grizzly bear, polar bear, and pandas. What will you do? And you have 2 weeks. You have to train the model, which is the easiest part. You have to look for the data. You have to clean the data. Those are then label it. Nobody's talking. We are 7 minutes past time. Hello? No, but why is people not interrupting me now? You people are making the and me.
I'm gonna think through what you're saying. I have no clue, by the way. I'm just thinking. So you're saying we have to get the data set itself. So we have to go get photos of dogs and all these, whatever.
Oh, bears. Yes, bears. Panda
Okay.
bears.
Maybe I don't know. Like, are they like just like you have Kaggle? Are there like repositories of?
Imagine there's no repo. There's no Kaggle. Did not exist. Google it. That's the first thing.
You can buy the data. Thank you.
You buy the data. It doesn't exist. So I will say, I'll first come to Google. Types of beer. Like I said, I've told you, as a machine engineer, once they give you a task, you cannot go back and say, That's the first thing, because I'm telling you, there's one Chinese guy in the class that will say, thank you, sir. Thank you, sir. I will come back with results. It can be a bad model, but it will not say no. So I'll say brown beer. These are the types of beers. You go and research on the project type. That's the flow. I'll now come here. Brown beer. I'll come to images. These are images of brown beers, but are they free? This is where ethics come in. You have to come to tools, usage rights, Creative Commons. These are free images that you can use. Because it's not that you go and do image and create a fine model, your company will now come to lawsuits. Your company will now come to lawsuits. So you go to Creative Commons and pick all the beers in the there. Now, are you going to now start coming to click and say download? No. There's something called, what is it? There's something called, no, it's not called Mozilla. There's a plugin. So this is, we're already moving away, but I'm just telling you, there's a plugin. There's a plugin called what? What's this? This is it, brown beer. Brown beer images. So this plugin, right? You can see it. Look at what it's saying on my screen. It will download all the images right now. This is for images, right? I'm just showing you what I do. Download all the images, and I'll go to what? Creative Commons. Right? Creative Commons is that it's shareable, you can use it, it's free. Nobody cares. I've forgotten the name of the plugin now. I can remember like this. The name of the plugin is, I don't know. Download all images. It's called download all images. So once you do it, look at, once I click on it, you will see something, see it, 100% done. To download all the images, so this is what I will do. I'll go to brown beer. I'll make sure I have maybe 1,000. I'll go to this. I'll make sure, because when I go, this is it. You understand? This is it. So this is one of the ways you use to source for data. There's a heart to sourcing for data also. You know, when you source for data, because many machine learning engineers just sit down and say, do you have the data? If you don't have data, cannot work. But you stand yourself out by saying, you want this? Explain the statement to me. Is this what you want? So this is the data that we have. This is, you can see it took my picture too. It took all the images. Let me close. Let me come here. All the images of brown bear. So you can see this is where your cleaning now comes in. This is where your cleaning now comes in. You can see it chose this one. You know you have to delete this one. You now come here. It took my image. Am I a bear? No, I'm not a bear. You see all these ones. You now clean it off and then boom. Right? So I'm going to add all these images there. I'm going to add it. I'll leave it in the training set. Why? Because there are variations, there are noise that the model will become smart and adaptive to. Right? I will take this one out because it's neither brown nor is it a beer, it's a drawing. I'll take it out. So stuff like that. So you are well, like I said, you are well on your way to becoming, state of the art. Where's that? Where is the notebook that we're on? It's not, yeah, but it's here. You understand? Well, you are well on your way to becoming, because you're around here. Yeah. Right? So first, Google is a good resource to source for data, look for plugins. Your problem, a lot of people have it. Do we get a copy of this notebook? Yes, you do get a copy of this notebook. So in the course between now and Monday or say Tuesday, you get an assignment of data sets for regression and for classification. I'm supposed to end my session this week, being my fourth class, so we can move into AIF third version of the week. But I'm going to discuss with Israel and AIF executives to see what we can do, if there will be an extension. If there will be, we'll have to shrink and compress and do. I think the best next thing to do is AutoML, because we didn't do one of the things I had promised you guys was supposed to be was supposed to do this audio classification, recommender systems, text classification, object recognition, segmentation, audition. But that being said, understanding of, I think what you have is very, very, foundational. And, I think there's nothing you can't, if you understand the notebooks, there's nothing you can't attack head on. And if you Google anything, so if you say, oh, I have a problem on image classification. Just what, though? Imagine I just attended this class, or I say image classification tutorial, right? I'm on Google image classification tutorial. These ones are saying simply learn. No, when you come here, you will see that everything they have on any random Google page, you have experience to it. You have sklearn, matplotlib, CV2, TensorFlow. It's not anything. You can see the class names. So they have the class names, number of classes, target size, right? I think here they're using TensorFlow. So it's just the way they write their code. Look at, they're using a sequential model. You understand? They are training the model. They are using Adam Optimizer. They are using sparse categorical cross entropy. Their metric is accuracy. So all I'm saying is you have something foundational that if you look at any other resource, it won't be alien to you. You understand? It won't be alien to you. You should be able to find your path and say, oh, okay, these people, they wrote this code better than Mr. Tolu, right? They wrote this code better than Dr. Tolu. It doesn't matter. Do you understand? You'll be able to find your path. So, to avoid the risk of talking too much, thank you very much, everyone. Any questions before we end today's class? Any questions? No questions. So,
Hello, sir.
yes.
Hello, sir.
Steven.
Okay, you mentioned, I wanted to ask, it keeps skipping my head because I wanted to pay attention. The sparse categorical cross entropy and the categorical, we've been using categorical cross entropy. Now, we always hear of sparse categorical cross entropy. Is there any difference between them?
Yes.
The sparse there, what's the difference?
There's difference. So I usually like using the AI to generate answers for me. Now, sparse categorical, they're both loss functions, but categorical is used when true labels are one not encoded. Okay. While sparse categorical are used when the truth labels are not used. So now, in this scenario, for many situations, we use one not. Most times we use one not. Yes, Emmanuel, this is bad, but bad has been integrated with the browser. So now, in many situations, right? How is it? How do I? Two of them use the same thing. Two of them have the same loss function, but categorical does one not encoding. What one not encoding is that, say in our images, where is this? So if you look at this, this one, all the labels are French, German, Golden Retriever, Poodle, Yorkshire. In categorical, it is converted to 0, 1, 2, 3, 4. In sparse categorical, you can write French Bulldog, German Shepherd, Golden Retriever. Sparse categorical can take the true labels, the labels as they are. In categorical, you have to do one not encoding.
Okay. Makes sense. Yes, very well. Makes sense.
That's the meaning of this. In categorical, when the true labels are one hot encoded. But in sparse categoricals, you when the true labels are integer encoded. Wait, sorry.
So does it carry out the one hot encoding automatically, the categorical? I'm talking about the categorical now, because there's no place where you apply one hot encoding in your data.
that is automated. That one is not a problem. I'm coming. I don't want
Okay.
to mislead you by what I read. Just give me. So sparse categorical does integer encoded. You know what? Next class I will define it. Just
Okay. No, let it be an assignment. Let's go and find out.
no problem. I'm going to define it already because I also need to read it up. So no problem. I will
All right.
define it.
All right. Thank you, sir.
Yes. So thank you very much. I would talk to you
Thank you so
guys.
much, sir. I appreciate you.
And please sit the quiz winners we'll get to know on Wednesday on next class. Hmm? So take care of yourselves. Have a lovely weekend. Ciao.